All right, so on Friday when we were together, our focus was on squares and rectangles. And what did we say the area formula was for squares or rectangles? Nora?
For square, it is, I don't know.
What do we say for squares, Harper?
Side times side.
Side times side, because all of the side lengths of a square are the same. We just did side times side or side squared, we said. Okay. What about for a rectangle then? Nora, what was the rectangle?
Length times width.
Yeah, so a rectangle we called that length times width. We also introduced the idea of maybe calling that base times height. Those are interchangeable terms. And the base and height, or the length and width, form a right angle. Lily?
And we also did parallelogram.
So we started looking at the parallelogram, right? And we said, actually I showed you this visual where we had this piece of notebook or of computer paper. And we said, we've got this rectangle that have a length and a width. If I cut it at a slant and move this over here, now I have my parallelogram that has the same area, right? Mm-hmm. So that's where that area formula of base times height came from. But remember we said that the height of the parallelogram wasn't this diagonal side. It's the piece that forms the right angle with wherever the base is. Okay? So I think we went as far as maybe labeling base and height on your parallelogram as well, right? So we had this kind of dashed line drawn in, making the right angle, and we called this our base and this our height, right? All right, so we're going to pick up there and start with parallelograms today. Knowing that our area formula is base times height, let's start with this blue one. Which two pieces are you going to pick for your base and your height? Remembering they form a right angle. Rex?
3 yards and 2 yards.
Good. Go ahead, Duncan. So here's our right angle. The 3 and the 2 form that right angle. So for area, I'm just doing 3 times 2, which gives me.
6
And what label am I going to put on this since it's area?
yards squared.
Good. 6 yards squared. And that's all. Base times height. Those form the right angle, and that's it. What about for this pink one? What dimensions am I using as my base and my height here? Base and height here. Molly.
3.25 times 3.5.
Very good. There's my 3.25. It forms a right angle with that bottom piece. In your calculator right now, unless you're doing this with long multiplication, see if you can get me an area. 3.25 times 3.5. 11 point what?
375.
375. 11 and 375 thousandths. Label is what? Feet squared. Feet squared. And keeping in mind, I'm leaving that squared unit on the label. That squared unit goes on the label, on the feet. It does not go on the number. So we're never going to write that as 11.375 squared feet, because then that's a totally different number. Okay, you can't put the label on the number. Put it on, or you can't put the squared on the number. Put it on the label. All right, last one, this orange one. What dimensions am I using for base and height there, Lily?
5 inches for base and 1.5 inches for height.
Good. My right angle is out over here. 5 times 1.5 gives me an area of 7.5 inches squared. Now, one thing to keep in mind looking at all three of these, notice how on the blue one, the height is drawn in the middle of the shape, and on the pink and the orange, the height is labeled on the outside of the shape. It does not matter where that height is drawn in. That height will always typically be drawn in with that dashed line, so we can see that it's not an actual side of the parallelogram, it's just giving us that height. It doesn't matter if it's inside or outside. If it's drawn inside like this blue one, it does not mean it's cutting this piece off. It's still the full parallelogram. It's just drawing it kind of in the middle so you can see that distance, okay? All right, in your notebook off to the side real quick, I want you to label, you can do this on a separate sheet of paper, the next page, or if you've got space. 1 through 6 is what you're doing. And you're going to look at these 6 shapes, and you are basically going to go through and you're going to calculate, do they have an area of 16 square centimeters? or do they have an area that's not equal to 16 square centimeters? So looking at all 6 of those, I'll give you a couple minutes, and then we'll go over them together. All right, here we go. Starting with number 1, what did you have as your area for number 1? Equal to 16 or not equal to 16? Not equal. If you actually calculated that, we would have had 12 square centimeters. Number 2, what did you have as your area?
16.
Yeah, this one you only were given 2 pieces, so it was 8 times 2 is 16 square centimeters. What about number 3?
Nope.
Yes.
Number 3 has thrown people off all day. If we look at number 3, what did we say the base and the height have to do? They have to form a right angle. So right here is where that right angle symbol is drawn in. What 2 pieces does that connect? It connects this piece and this piece. 4 times 4 is 16 centimeters squared. So that brings up a really common misconception we have with these. A lot of people hear the word base and they automatically assume that base is bottom, or the piece that it's sitting on, because that's kind of a natural assumption to make. Just because it's sitting on this bottom piece, that does not mean that that's the base. You always have to find that right angle first and then use that right angle to calculate it. Okay? So 3 was a yes. Number 4 gave us a mixed number. If you did the math on this, let's see, 6 over 1 times, what is 2 2/3 as an improper?
8/3.
8/3. I would recommend simplifying on your diagonal before you multiply. So these are both divisible by 3. That turns into a 2 and a 1. That makes it a lot easier. 2 times 8 is 16. 1 times 1 is? So that one is equal to 16 centimeters squared. Number 4 was a square.
Yes.
16 centimeters squared. And number 6.
Yes. No.
Here's my right angle. 4 and 3.5. 4 times 3.5 gives me an area of 14 centimeters squared. So that one was another no. Okay. So we had no's at 1 and 6, and the rest of them were yes. Okay. All right, so let's fill this in on your notes. We already labeled your parallelogram. So on the inside of your parallelogram flap, we're going to write the formula. Area equals base times height. And you're going to draw this parallelogram in. Go ahead and sketch that into your notes. And what pieces am I going to use for the area here? 10 and 2.5. Very good. So I'm going to do 10 times 2.5. Good. 25 centimeters squared is the label I'm putting on that. Centimeters squared. Give you a second to get that written down. All right, so now we're going to move on to triangles. And before we do triangles, I want to show you real quick visually how I'm coming up with this formula. So same thing, I'm starting with there it is. I'm starting with a full sheet of paper, like printer paper. We've got a rectangle, right? So all of this area, all of this pink stuff, base times height or length times width gives me the area. If I make a cut right down the middle and I get rid of that piece, what am I left with?
Triangle.
A triangle. And how much or how does the area of this triangle relate to my original rectangle?
It's half.
It's half. So when we're finding the area of triangles, we're going to do that same base times height, and then we're going to cut it in half. And we can either do that by multiplying by 1/2, or what most people prefer to do instead of multiplying by 1/2 is just doing base times height and dividing it by 2 at the end. Okay, so same thing, we're going to be looking for that base and height. So in this pink one, what two pieces make up my base and my height?
4 and 2.5.
4 times, so we're going to do 4 times 2.5 and then divide that by 2. Kylan?
5. I got 5 yards squared.
Good, 5 yards squared. So 4 times 2.5 was 10. 10 divided by 2 gave you 5. What about for this orange one? What pieces should I be using for the orange one? Vivian?
4 and 3.
Good, the right angle is 4 and 3. So for my area, I'm going to do 4 times 3 and then divide it by 2, which gives me 6 inches squared. Very good. And for this very last one, my green one, which two pieces am I using for the green one, Elias? 5 by 5. The right angle is down here, connecting the 5 and the 5. So we're going to do 5 times 5 divided by 2 is 12.5 feet squared. Okay. All right, somewhere off to the side, so maybe where you did those 6 parallelograms, I want you to try to do these 2 triangles on your own. You can use a calculator, but just real quick, you're going to do base times height divided by 2. Make sure you're paying attention to where that base and the height are based on the right angle. And then we'll go over these together in just a minute. All right, should be some quick calculations here. For the first one, walk us through what you did for that top purple one. Nora?
I did 8 times 6, and that equals, I forgot what it equaled, 48, and then divided by 2 equals 3.
Very good. 24 square feet. What about for the second one, the green one? Jonah?
16 times 10, which is 160, divided by 2, which is 80.
Very good. 80 square feet. So both of these are good examples of how the base was not the bottom piece that it was sitting on. It was kind of on top or off to the side. Always finding that right angle first to help you with that. Okay, Elias?
I did for the second one, I just did 8 times 10 and 8.
So some people calculate area of triangles that way too. They just cut one of the numbers or one of the dimensions in half and then multiply by the other one. That's the same kind of thing, just a different order, so that's totally fine as well. That's actually a great strategy to use when you've got some bigger numbers like that, to make a bigger number smaller and make it easier to work with in your head. Yep. All right, so last thing, we're going to go ahead and fill in our notes for triangle, and then the rest of the time is going to be yours to work. So go ahead on the outside of your triangle, label your base and your height with that right angle. And then on the inside, we're going to write that the area formula is base times height divided by 2. And then I'm going to draw the prettiest triangle you've ever seen.
Beautiful.
You haven't even seen it yet.
I made my triangle the other way.
Then just turn your paper and...
That's
great.
smart. I know, I knew then. So, I think I did it wrong then.
You can't put the paper on.
I flipped it.
You flip it the other way.
Your notebook can spin 360 degrees, so you just spin that until it looks right. All right, so we've got base and height labeled on the outside. On the inside, we're writing our formula. Area is base times height divided by 2. And then you're going to draw that triangle, try to sketch it. And I intentionally picked this triangle because I wanted one where you can see that sometimes with triangles, the height is going to be labeled on the outside, just like for parallelograms. And that's perfectly fine to have it labeled out there. It doesn't have to be going through the middle. Okay, the definition of the height is from the base, forming a 90-degree angle straight up to the tallest point of the shape. So it's connecting that top peak or that top corner of the triangle. Okay, so who can walk us through for that triangle that I sketched? What am I going to do to find the area there? Leo?
You're going to do 3 times 2, which is 6, divided by 2, which is 3.
Very good. So we're going to call the area there 3 square centimeters. Very good. All right, the rest of the time is going to be yours to start on homework. You can use your notes as you work through this.